Okay, so
By doing this way,
can you hear this video?
the process
Can you hear it?
Yes. Yes, go ahead.
of changing the boot order, so you want to boot from a CD or a USB as opposed to the hard drive, you could do it this way. So the first thing we're going to do is we're going to restart our computer. Now, while the computer is restarting, we have to click on a key on our keyboard to launch the BIOS settings. And depending on your computer manufacturer, it could be a few different keyboard shortcuts. The most typical one is the F2 key, but I've also seen the escape and delete key used as well. Sometimes if your computer is booting up and you see something on the bottom of the screen that says press this key to enter setup, just click that key and that will get you to where we are going to go for the next step. But I'm going to be tapping on the F2 key. That is usually the most common keyboard shortcut to get into the BIOS. You can go online to look up specific keys for your motherboard manufacturer. I'm going to use the arrow keys on my keyboard to scroll down to the enter setup selection. And now I'm going to tap on the enter key on the keyboard. So now we've entered the BIOS. So using the arrow keys on my keyboard, I'm going to scroll over to the boot tab. So now if you want to move one of these entries up or down the list, you can just click the plus or minus key on your keyboard. So let's say I want the CD-ROM drive to be the first item to boot. I'm going to use my arrow keys on my keyboard to go down to the CD-ROM drive. And then using the plus symbol on my keyboard, I'm going to click it. And we see that it is slowly moving up on the list. And I'm going to click it one more time. And we see CD-ROM drive is the first drive to boot. So in order to save these settings, I'm going to click on F10. Save configuration changes and exit now. You're going to click on enter to accept. I do want to let you know you can reverse these changes to default settings at a later date if you want to. Just follow the shortcuts on the bottom of the BIOS to reset the settings at a later date, again, if you want to. So save configuration changes and exit now. I'm going to click on enter for yes. And the computer will boot from the CD if you have one inserted. If there is no CD inserted in the computer, or whatever your primary boot device is, it will automatically go to the next item in the list to boot off of. So I hope this tutorial helped you guys out, and I will see you in the next video. Goodbye.
Okay, so that is what the BIOS is. So it does more than just checking the system in. But right now, for our course, we are only worried about what BIOS is doing here. There is a lot of things it's doing, but let's just worry about at this moment here. The moment you power on the system, BIOS is activated, and it's sitting on the system board and performs hardware initialization. Okay, and then what else is done is you could change the settings here. So, for example, if the system is checking for your CD-ROM drive, okay, but if you don't want your system to check the CD-ROM drive, you could go into the BIOS and you could disable the check for CD-ROM drives. Okay, that's all it is. I thought we are able to go into BIOS here. Give me 1 second here. Let me see if I could get lucky here. Reset. Okay. So sometimes it's hard to comprehend what is happening here, but if you have, but if you have the computer or the laptop, you could try this here. For me, I have a Dell laptop here. If you want to go into BIOS, you could press F12. You can put in a Google and find out which key you would need to go into BIOS here. By the way, when I said in the start of the class, we need to enable the virtualization in the BIOS, this is what I was talking about. Okay? So I think the start of the class, if the system was not working correctly, I told you to go into BIOS and enable the virtualization. Okay? Alright, let's move on here. So BIOS does the checks and then it passes the control to bootloader. Okay? So what is bootloader doing? Okay, bootloader has two stages. Okay, stage one is called MBR, master boot record. Okay? Alright, so let's see where is the master boot record here. So I found this good picture here online, and the master boot record is on the physical drive. Physical drive, there is a little cylinder that holds the information. This is where it's read. After the BIOS, it passes control to the hard drive, and this is where the master boot record is. Okay? In that master boot record, this particular section, it has two, stage 1 and stage 2. Okay? So stage 1 is, the bootloader. Okay? I'll show you in a minute here. The bootloader, the first part of the bootloader is master boot record. What it does is, it initializes the operating system. So if you have a Windows operating system, it will initialize the operating system. But if it's a Linux, then it will put on Linux, okay? It will initialize it, it will wake it up. And then all it does is, it does that. So this part is doing that here. Master boot record part is doing that, okay? And then master boot record passes control to second stage. Okay? So stage 2, it starts reading in the Linux, particularly Linux, it has a boot, /boot. So we went in there /boot and then we saw so many files in there, okay? So let's go in there. I'm going to change the appearance to 16 here. Okay. it has all these files here. Okay, so you could go there and look at it a little later here. But the concern file we are worried about is, okay, so it goes into this boot folder and the important files in it. Now the stage 2 is in control, okay? And stage 2, what is happening is the kernel is getting kicked in. Okay, this is a kernel which has set of instructions here. Okay, so if you do ls-l, okay, so boot folder has this VM Linux 3.0. This is the kernel here, and this is the version of the kernel. Okay, I'll show you later how we're going to update that. And then let's see in the 7 also. This is the kernel we have here. I'm sorry, this is stage, the other one is 7. So this file is being read here. Kernel will do the following. It will detect all the hardware. BIOS did it, but now the operating system is detecting the hardware, okay? And it will initialize. That means it turn on the software for the hardware. Software means in the common sense, it's called drivers. Okay, but in generally speaking, it's nothing but a software for the hardware, okay? And also it mounts or loads the root file system into read-only mode. So root file system is not /root. It's just /cd/. So all these file systems are root. Actually, this is the root file system here. Okay, I'll explain a little later when we go into LVM here. So this is only read-only mode at this moment here, okay? And then it kickstarts the init process as bin/init. It's written in binary. Okay? In other words, OS initialization, okay? It's called OS initialization. All this process from here to here is called operating system initialization. Okay, this is a pretty good thing here. Okay, this is the boot record. This is the first stage. Okay, and this is the second stage of boot, master boot record. Okay, it says boot record CD. Okay, this picture is not clear here, so I will edit this and put it on. Matter of fact, let me do it right now. Okay. So, yeah, master boot record, boot record. Okay, so, and then let me just get rid of this too. Boot record. For now, this is all we need here. Okay, this is correct.
Because Zafar, we can see the boot record, master boot record, but there is a bootloader. The whole thing is called the bootloader, or what is the bootloader?
Bootloader is master boot record and boot are the part of bootloader. Bootloader, stage 1 is master boot record and stage 2 is Stage 2 is boot. Right here, you see boot record. Okay, let me just...
No, that I'm looking at that one. How we say, but this is a part of the bootloader. And this is at the very beginning of the hard disk, in the very beginning. So where is the bootloader that contains these two?
Bootloader is actually 2 here. So bootloader has 2 stages, I'm saying. Bootloader is boot record and master boot record. These two are bootloader. Okay, BIOS after it passes control is a stage 1. Master boot record is stage 1 and boot record is stage 2. Okay?
Got it. Thank you. I got it. Thank you.
Okay. Stage 1 master boot record and stage 2 is boot record. Alright, thanks for reminding me. Okay, then it loads it goes in there and it has important files in it, okay? Now the stage 2 is in control and it's going through all this here. These files are getting activated and whatever is written in those files, based on that the system is bringing the system up and it will be ready for you. Okay, so now this 2 is done. Boot record and MBR is done. Then what is happening is it's passing the control to OS, operating system. Now the operating system is running through all these files. These are very important files. So /init, this is a file. You could go in there and see this file is there. And then this file is telling the system to go through all the other stuff. So when this file initializes, it's telling the system to read the file init file type because it will tell you what run level the system needs to load. Then after that, init file type is still in control. And it tells the system to read this file here. Okay, what is this file doing? It's configured the host name. Okay, we'll go through that host name what it is. It configures the IP address. It configures the security. It remounts the root /root into read-write mode. Okay, earlier /root is only in right here. /root is only in read-only mode. Now it's changing into read-write mode. Okay. Alright, so let me just highlight this. All these are very important. I'm going to put together a questionnaire that some crazy guy will ask you in the interview how this process works. If you just memorize and send it to him, he probably won't ask you more questions. Okay, and what else? All these files here. Okay, and everybody is clear about binary, right? What is binary? So this is what is happening here. This is CPU hardware, and this is the kernel. Okay, I think this picture is wrong. This picture is wrong. Okay. BIOS, MBR, graph, kernel, init, run level. Okay, yeah, this is a good picture here. This is a good visualization, very good. So in a nutshell, this is what is happening. What is happening here? Hmm. Okay, it's in the middle of the... Okay. So you power on the button, and then it happens is BIOS takeover, and then MBR, and then graph. Okay, what is graph? I think I talked about graph, right? Did I? I'm just saving, I'm not telling you what graph is at this moment here because it's going to confuse you. But I'll just show you at the moment here. Don't worry about it, graph at the moment. Okay. This screen, what you're looking at is graph, okay? Okay. So we went in there and we did some edit here. This is Windows, Red Hat 7 here. But let's look at the Red Hat 6. We already had went into graph once already because there is no way for me to move forward without showing that to you. Okay, so you see here is like graph, G-R-U-B. Okay, so where is that going to come? Uh, Rotor has initializer. Okay, so the stage 2 is in control and graph is loaded. Okay, right here I said push each for grub menu here, and I mentioned here and okay, so let's move on here. So graph is loaded. Actually, this bootloader is actually a graph. Okay, so I was using a generic term bootloader, but this is a grand unified bootloader. GRUB stands for grand unified bootloader, right? Let me check that. What is GRUB? Right here, grand unified bootloader. It stands for grand unified bootloader. Okay, so bootloader, we have two stages. Stage 1 is MBR, stage 2 is boot record. So stage 1, stage 2. Okay, so then after that, the kernel. Okay, after that the kernel is initialized here. Right here, the kernel file will do the following. Okay, so after grub kernel takes it over, and then after that the system D or system V based on system D services or system V. System D or system D, system V for rel 6 and or starts the system D for rel 7 starts based on run level. Okay, I'm going to go, what is system D and system V? We're going to go that in a little later. Okay. And then targets, we'll talk about what targets is little later. Targets is only on Red Hat 7. Targets is run level. Targets is run level. Okay, for 7, we say run level for 6, and for 7, we say target. Okay, yeah. Okay, that's the story there. Okay, so it's complex here. All these things is happening. By the time you push on the operating system, by the time it's ready to put in the root password, all these things are happening here. Anything that goes bad during this process, that's where your Linux skills will come in, and you will be troubleshooting this part here. And this is why you will be getting paid here, because Linux operating system is running very, very important things on it, like a database, database is being run on Linux, all the other, it depends on what is really happening here. When I was working for Apple, some of the important things they were running is Apple Store, iCloud. If you work for Google, I'm pretty sure Google Maps are running on Linux and all those here. So you'd be surprised all these important things will be running on it. And that's where your Linux skills will come in. Okay, so let's move forward here. So, I mean, I would say don't stress too much on this. Just keep this in the back of your mind. Most recent interviews, I haven't seen anybody asking about this. But if you are going for, say, if you're going for an engineering job, then they might ask this. If you are going for an admin job, they will definitely not ask for this. Okay. All right, so let's take a 5-minute break and then we'll come back in 5 minutes, okay? Let me stop the recording. Okay, I'm back. So, let's move on. Okay. So the next topic I'm going to work on is disk management, okay? So we're going to go into the hard drive, and right now we have only one hard drive attached, right? You go into settings, and then you go into storage, and we have only one hard drive. So in real world scenario, it doesn't work that way. You would have multiple hard drives here, okay? So before that, can somebody confirm you could hear me?
We can hear you. Yes, brother, Zafar, we can hear you.
Okay, good. So this is called a disk management. So we're going to work on this. And let's see here. I'm going to put this as the cover. Yes, a new topic. So most of the time, the system is dealing with a disk called SCSI. Okay. All these are short forms here. For now, I'm not going to go into deep in there. I'm going to just say what these are, because some of them have like old technology in it, and the ones we are using are SCSIs. Okay, so the one in the old days it used to be called. So remember when I said /dev / can't type. Is the system off? Oh, system is stuck here. So just reset it, okay? Hmm? Not able to type. Okay. Okay, remember, when I talked about /dev, this is a folder into root. And I said it contains all the device file information, okay? The hard drive, the Linux operating system manages the hard drive and the file, okay? I think I mentioned earlier, don't be surprised that everything is files and folders in Linux operating system. By the way, there is no easy way to learn this in the order how things are going. There is absolutely no way you could learn things in the order. Okay, from the start you learn this, and then step by step. Because what you're learning, we just finished with the booting process, right? That is very first thing that I have started. That's how the system starts, and we are learning it like 2 months into the course. Because there is no way we could learn all that in the order how the system is working. So, okay, so I thought I mentioned somewhere that the Linux operating system is nothing but files and directories.
Yes, but I remember you talking about that in the beginning when we were installing and we were in the initial lectures. Yes, I remember that.
So maybe not here. It's okay. If you didn't remember it, but I'm saying it now that all these things are the Linux treat everything as a file and a directory. That's it. That's how it's going to be working. Okay, so let's take a look here. Okay, let me log in as Red Hat. And 7 root. Okay, I think it's a different number, right? For 7. One 94.3. That's what I was putting in. You think it's acting up again now? Working. Okay, so you go into /dev folder and you do ls, okay, ls has an L. All these are devices here that you are not worried about it at this moment. What are you worried about? Okay, let me introduce a command, df-h. When you type this command, it will show you the disks which are attached to the system here. And this one is a root file system. This is your hard drive. And then these are the system generated. These are only there for, these are loaded into memory here. But this file system here is a hard drive here. So it's going into this folder here, dev/mapper. So let's go into cd mapper. So what we have is, we have the root file system, hard drive is listed here, and swap is listed here. Okay, so I'm not going to go into what swap is, but let me just put this together here, what I'm going to say next. So in the old days, little bit older days, you would have an IDE device. So you guys could do some research on this here, because I'm not going to show this here. IDE, it stands for Integrated Device something. And then, you know how the operating system will handle this? Linux will handle this as, will handle these kind of devices. So it would be in dev folder, and then it will be showing as HDA. Okay. All right. So the other kind of drive is called SCSI. Okay. So SCSI, I think. Yeah. And Linux will handle these kind of devices as, it will be handled as dev/SDA. Okay, yeah, I thought I typed SDA, right? So the word is auto-correcting. Okay, and then you will see a little later what I'm talking about. And then if the drive is a virtual drive, Linux will handle these kind of drives as devices as. So it will be listed as dev/SD VDA, sorry, virtual drive, whatever it is. Okay, this is how the Linux operating system, it will show in the Linux here. So if you compare with Windows, and here, this is my hard drive here. It's showing as local C colon, and I have a DVD drive that says local E colon. So Windows has A, B, C, D, E system here. Okay, but Linux, we're going to concentrate on SCSI here. Okay, so let's see here. So we'll worry only about the SCSI drives here, okay? So that was just the intro. So the very first drive, the Linux will have, you have to have at least one drive to be able to work with it. So the very first drive is going to be dev/SDA. Okay, this drive will be first primary drive. This. Okay, and this is also called a boot drive or a OS drive. And this will be reserved. Okay, so if you have a computer and you have only one drive attached to it, it will automatically take that one drive to install the operating system. But if you have more than one drive, then you will get an option which drive you want to install the operating system, okay? Just remember that. So once it has like dev, it has a second drive. How is it going to handle the second drive? It will handle the second drive as SDB. Okay, second drive. And the third drive, can somebody take a guess? Third drive will be SDC. And the fourth drive will be dev/SDE. So it will go all the way to
so the letter D will be letter D will be missing the fourth drive. It won't be SDD.
Yeah, it will be D. SDD, yes. So it will be all the way to SDZ. SDZ will be the 26th drive. And when you go into your job and you have like more than 50 drives attached, don't be surprised. That's normal. Okay, so I said there will be more than 26 drives, right? So the 27th drive, how the Linux is going to handle the 27th drive? It's going to go SDAA. Okay, from there, SDAA starts. So this is like a 27th drive. And then how is the 28th drive is going to be? If you have like 28th drive, so
SDAB.
AB, exactly, very good. So you could imagine this is how the Linux handles it. And if it's an IDE device, it's going to do SDA, SDB, and all that.
And how normal is that to have the lot of drives attached to one
very common.
Linux system?
At least 50. If you see a database that has like 50 drives attached to it, it's common. Don't even be surprised.
Got it. Thank you.
Okay, so alright, let's go into the operating system here.
So for the time being, we shouldn't be worried about the IDE drives or the virtual drives. So we are practically looking at the physical drives.
Yeah, IDE drives is obsolete. They're not using it. I mean, the technology is like 10 years old. I mean, it went obsolete 10 years ago. If somebody is using IDE drive, then they have some serious problem now. Because I'm not sure how the IDE is being used. While the new system, I mean, that means they're not keeping up here. I mean, don't worry about it. Any big corporation, whoever is running Linux, they have like a big fat budget for the IT department, or else they won't be able to function.
So now the tape drives And what nowadays the latest technology, not too latest, but SDG drive, they are also come under this SCSI.
As long as SCSI, then it will be SD drive. Yes.
No, I don't know what SCSI is. I just heard the name. If I research, I might find something. I'm talking about the SDG drives nowadays. They have a chip kind of drive. They come also under the name SCSI, or it would be something else. If something SDG kind of drive is attached. I might be asking a stupid question, but
No, that's a good question. Usually, the job I'm preparing you for, usually you don't have to do a lot of hardware work. They would be doing, usually this is what's happening these days. One person is not doing everything. Linux admins, if there is a huge data center, right? Everybody know what a data center is, right? Let's see here. So this is a data center, and it has like rows and rows of. It has rows and rows of computers, racks, filled with servers here. And this is highly restricted access here. So the person who is going into the data center, setting this up, and all those are site services. They may not have a Linux background. They'll just do that's a grunt work. You don't want to be working inside the data center. It's a lower paid job. So what they do is they just do the networking cable and all that and plug that in, turn it on, and then from there your job starts. You don't have to have access to your data center. You'll be working from the desk. Okay? So I think this is a Google or Amazon data center. And they have rows and rows and rows and rows, never-ending, computers. This is why it's called cloud. Everything goes and sits in this physical place. Let's see here. Yeah. Okay, usually what they are doing is they are putting this in a rural place. In a country where it's far away from cities and it's kind of hidden, nobody knows they have a data center there, and they would be able, there is no this is, you could see it's as big as football fields, and it has like a cooling system and all that. So this is where all your Apple and Google stuff is going there. But let's not worry about that because we're not shooting for the job. We're shooting for the Linux administration or engineering job, okay? So let's see here. What I'm going to do is let's go ahead and add a hard drive. I'm going to go into settings, and then I'm going to go into storage, and then I'm going to click here, and then I'm not able to add a hard drive now because I have to shut the system down. I'm going to power it off, and I'm going to power it off again. So from here, going to settings.
Do you have more than one hard drive on your system, brother?
No, in VirtualBox you could add more than one.
Okay.
Okay, so here you select controller setup. Okay, and then you add a hard drive. Add a new storage controller. Okay, click a plus sign here. Click a plus sign here. Add the hard disk, the second one. Okay, and then just leave everything else here. SATA is like a connection cable. How the connection is this? Oh, look at this. This is the IDE. You know what? I never tried it. Let's go ahead and add the creator disk. And okay, here it's saying you want a virtual disk or virtual iDisk VDI. Let's keep it VDI. Okay, you could play around with VSD and VMDK. But let's keep it VDI. Let's go into expert mode and okay, 8 gig is fine. Okay, leave it 8 GB default and then leave everything default and click create. Okay, now here I'm gonna go click create a new disk and click create. Okay,
so did we add 2 hard drives or did we add 1 hard drive? This is the process for the 1 hard drive.
yeah, we are adding 1 hard drive into the SCSI, another one we added into the IDE. We are not gonna worry about IDE here. So just make sure make it 2 here, and then click create. Okay, so under here we have the virtual disk here, and then the virtual disk here. You know what? Don't worry about ID here. I think you will get confused here, so I'm going to just remove it. Remove this. You can play around on your own. Okay, so let me just click OK here, and then go for storage. Click here on the controller, plus add, create a new disk, VDI, and then dynamically allocated, yes, leave it alone, and then give it a name number 2, and then click create, and click OK, and then kick it out. Okay. Yeah.
One quick question, please.
Yeah.
In our case here, we have the virtual box and we have a GUI interface and we added a new hard drive. In the actual job, do they have some graphical tools to add the hard drives, or how do we do over there? Because they don't have virtual box there and there.
Yeah, virtual box is VMware. We're gonna go over that, okay? That's a different thing, so you don't have to worry about much. If you get a request to add a new hard drive, you just tell the site services, add a new hard drive. They'll add a new hard drive and they'll tell you the hard drive is added. Okay? So
Got it. Thank you.
What we did here is physically the action we did here is as if we have physically added a hard drive, okay?
Got it. Thank you.
Okay, good. So what I'm going to do here is I'm going to go tab a little bit, inside a box. So we added a hard drive, about 8 GB hard drive, right? So we added a physical hard drive here. Okay? So we added a physical hard drive. That doesn't mean the system is using it right away. You have to configure it. So let's go in here and root. Okay. So what is the command you would see df-h? Okay. We added a hard drive, but it's not there, right? Here it's showing SDA. SDA is the original physical drive here. Which one is SDA? If you go in here and go into settings, this is the SDA one. Okay, but operating system doesn't see SDB. So how are you going to find out if the hard drive is attached to the system? You're going to do cat proc partitions, and you will see that the hard drive SDB is there. I'll explain you SDA. It's showing SDA and SDA 1 and 2. It's like a partition here, but don't worry about it. Don't look at this. Just concentrate on SDB. Okay, so the hard drive we have is /dev/SDB. Okay, so let's see if it's in there. cd/dev, okay, ls, and cd SDB. Okay, the file has not created yet, so we're gonna have to create a file system for that.
I think if you try to do the CD, there could be a file, might not be the drive directory. So if you just do the ls or whatever the.
Yeah, it's not there.
And do you mind if you put the command here also dfs
I will.
and partition. Okay, thank you.
So you type SDB, okay? The hard drive is added. So add a new hard drive, but it is not ready for use yet. To see the hard drive, which is added, do the command cat proc partitions. Okay, what is proc? Proc folder is a memory. So when the system boots, it loads it into memory. So this is what the BIOS is doing. BIOS detected the hard drive, and it's kind of telling it kind of had loaded all that into the memory. So the root file system is now into read-write mode. Before it, at one point, it was loaded into read-only mode, and then this process here it loads it into, where is that? So it mounts. So all this process of all this is happening in was read-only mode. And when is it read-write mode? Okay, right here. So the init, one of this file when it executed, it loads it into read-write mode. I'll take this method. This is not /root, just root. Slash. Everybody knows there are three kinds of roots, right? Slash is a root. /root is a root directory. And root is the name of a administrator. And /root directory is the home directory for the root administrator. Okay? Any confusion there? Okay, good. So you would do cat proc partitions, then you will see the hard drive in there. Okay? So what is the copy we're dealing with? We're dealing with the one we just added here. So this is the output here, and when you look at the output, this is what you'll be looking at. HDB. That's a 8 gig hard drive. Now I'm not sure if it really is what it's saying is 8 gig is what. Okay, so we'll talk about this, what it means here, okay? It here it says it's giving you in the bytes here. So we could do df hyphen set get hyphen h, get no partitions. Okay, don't worry about that. H. No, don't worry about that. Okay? Alright, so what we did so far is we added a new hard drive to the system here. Okay, and what is the size of this? This is a 8 GB. It's an 8 GB hard drive.
But it's just a minor typo. As a DB, not as DB.
Yeah, thank you. Okay, so this is how it is. So to start using it, what we need to do is we need to run some fdisk commands. So what we're gonna do now is we're gonna do fdisk commands here. Okay. Okay, so this operating system, it has an old fdisk command. Fdisk command is coming all the way from the Unix operating system. When the Unix was created, this is a very original command they used to use the fdisk command. Okay, but before that, there is another way you could check the hard disk in there. So you called the command is lsblk. ls stands for list block. blk is block size. So when you type this command also, you would see SDB there. You see SDB is sitting there and getting wasted here and nobody's using it. So this is a very good, another very good command you would use to see the hard drive is there or not. Okay, so So use the command either cat proc partition or lsblk. I prefer lsblk better than cat proc partitions here. You know what, actually, yeah, this is used for something else here. Don't use this command here. Okay, just use a cat proc partition. And where is the hard drive we have which is getting registered here? Is this one here. Alright, so everybody agrees, right? This is the hard drive we have added here. It's 8 gig. You could confirm it's an 8 gig hard drive. Okay, so let's do lsblk. And so the hard drive is being shown here. So let's do it on the other one, lsblk. And you see the SDB is there and it's 8 gig and it's sitting around. Okay, good. And then what else you could do is let's see what is the use of cat proc partition. I think let me clear this. Okay, I'm going to show you only on one system here, okay? It's going to be the same thing for 6 or 7. It's going to be the same thing. So you could practice on both of them. So before that, let me go into dev. And then I'm going to do ls here, but it's not there. So what I'm going to do is, I'm going to do, if I want to filter out what command do I use?
We can do that, but can you do the ls and do the more or less so that it will stop? It might be go on top.
Okay, let's do ls-l and we're going to do sd asterisk. Okay? So right now, root is the owner of this here. So we'll go into that a little bit more here. So you can do this command to see if the hard drive is being detected by the system here, okay? So let's see, this is a good command too, so let me copy that. And then what else you could do is cd/dev, then you do ls ls-l, and then you do sd asterisk, and it will show you that devices is being detected or not, okay? Now, what we're going to do is, the command is, we're going to use fdisk, okay, /dev/sdb. Okay, this is the command we're going to run. Somebody might know what fdisk is, right? So fdisk. By the way, you could be anywhere where you could be running the command. So that's the beauty of the Linux. fdisk/dev/sdb. Okay, so let me hit enter. So what we're doing is we're going using the fdisk utility, which is built into the operating system. Okay, so we have this thing come up. It's telling the device contains either a valid DOS partition table, Northern, blah, blah, blah. So I'm not worried about this. You're going to see that all this coming from the message here. So now we have a command here. So we're going to have to push M and hit enter. So it will give us a menu. So what we're going to do is, before we do anything, we're going to see print partition table. So we're going to push letter P. Okay, and hit enter. Now what do we see here is, for fdisk, we did fdisk/lgd, right? And then that hard drive is there, but it is raw. It's a raw hard disk and nothing is being used here. But you're getting some information here. So the disk/disk/lgd is 8,589 megabytes. That means it is a 8 gigabyte hard drive. And it's giving the information in bytes also. And it has 255 heads, 63 sectors, 1044 cylinders, and it's giving all this information. So this information, you could do some research here. I'm not teaching you the hardware class. So you could do some research here. In practicality, you really don't need to worry about all this. Not too much. Little bit, not too much. So let's go back into menu again. So what we're going to do is we're going to create a new partition. Partition is, we have an open space. Just imagine partition like a raw disk, like a big open space, like a big hall, big banquet. And what we're doing is we are making a partition here. We are making some sections in there, okay? So to do that, we have to push letter N, add new partition. Okay, I hit enter, and it is telling you what kind of partition you want to do, extended or primary. So most of the time you will be using primary. So hit 1, and you could create up to 4 primary partitions, and then you hit enter. Or you have to push P. Okay, and hit enter. It will automatically take as a primary partition, and then you have to push what number you want to assign. We usually assign number 1. If you hit enter here, it will automatically take that as a 1. If 1 is used up, then it will take number 2. So hit enter. Okay, it's still telling me. Okay, push 1 and hit enter. Okay, so it's telling you how many cylinders you want. Most of the time, you just hit enter, okay? And then it's telling you all these things here, so you still have some time to give the value. I'm going to hit enter. When you hit enter, it's going to use up the entire hard drive. Okay? Using the value 1044, and it is using the entire hard drive here. Okay, let's do the menu again, and then let's see if the partition is created. P. So the new partition has been created. The start of the block is 1, and the end is 1044, and the block size is whatever that 83 million. This one here. Okay, and then the ID is 83, and it has what this thing I'm trying to say is, it's using the entire hard drive here. And let's look at the ID 83. So I push menu, and then you have here change the partition system ID. So let's push T here and enter. Oh shoot. Okay, I messed up. So let me clear it. And then I'm going to go I'm going to do P here. So we didn't save it when we were exiting. So I'm going to create new, and then I'm going to create a primary partition, and then I'm going to give it number 1. Okay? And then here it says cylinders and all that here. So I'm just going to hit enter, okay? So it will take the default one. It's going to take the default cylinder 1044. Okay? And then let's look at the partition. The partition has been created. Okay? So let's look at the menu again. When you push W, it will write the partition table and this can exit. So what is it doing here? It will save and exit. So whatever we have created is going to keep it. Okay, so the partition table has been altered. That means the partition has been created. And what will happen is you have to now what you have to do is, before I forget, let me copy this command here. So you went in there and then you did F disk and then you hit N. Okay, you will hit letter M to create new partition, and then you hit P for primary.
Brother Zafar, I put the M as Mary also before N so that if somebody is watching, they know they need to click on the M to view at the menu.
Okay, good. Okay, view M to view menu, N to create a new partition, P for primary partition, okay? And then one for first partition, first primary partition. Okay, and then enter to use the default. Okay, to use the default cylinders, okay? In this case, it will use entire drive, entire disk. Okay? So it's just, we are just making one partition, we're just making one room. And then you type W2 save and exit. Okay? And after that, let's see here if the partition, but then there is another command you have to run. Okay, you have to type part X, that means partition X, hyphen verbose, hyphen A, and the name of the partition, /div/sdv. I mean not the partition, but the name of the drive. Okay, so what it did was start, zero, size, it did all this here, whatever it needs to do. To be honest with you, don't worry about too much here, but yes, you have to run this error here. Error adding partition 1, device or resource busy. Am I doing this on the right place? Okay. What you could do is you could go back in there, fdisk/dev/sdb and hit enter. And then you push menu and then you push P. Okay, yeah, the partition is there. Q to exit. Okay, but if you type DFFNH, the partition is still not being used here. But if you do LSDLK, now you see SDB, it has a SDB1 here. Remember we put 1 here, that's the primary partition, 1. And then when you try to create 2 partitions on one drive, which we will do next week, it will be SDB2. This one has been created by the system here, so it has partition 1 and partition 2. We could create up to, actually we could create a lot of partitions in one drive. 4 primaries, rest will be extended. I will explain that more next week. Okay, so let's try to use the SDB1 now. Okay, for you to do, you have to install. Now you have to make a PROTech partition X -V -A /dev/sdb. Okay, what it does is it will register that in the system. Okay, now we have to make file system. Okay, so the command to do make it a file system, that means you have to give it some kind of file system for the operating system to recognize what kind of file system it is. So most of the time Windows is using NTFS. Okay, but Linux is using ext4. Okay, I will talk about that file system few weeks from now, not now, okay? Because you will get confused. The command to make file system is nkfs. That means make file system dot. What kind of file system you making? ext4. And which drive you going to make? dev/sdb1. You have to be careful here. Which one you're using? SDB1. You have to specify this. And hit enter. So it's going through all this here and it creates a file system. Okay? So the file system will be automatically checked every 6 months and you could go in there and little bit do some research about it, okay? So MK2FS1 May 17. So this is the latest version it's using. And file system label is nothing. Block size is 10.4096. Okay, I will talk about what is block size 4096 later. And inodes. The system automatically gets the file inode. So what inodes is, you could have on this hard drive, you could have 524,288 files on this file system here. Okay, 104,802 is the block size. So this is reserved. Okay, first data block 0. I'm not worried about all that here. And the only thing I'm worried about is nodes. So it has 8,192 inodes per group. Okay, we'll talk about this when we go into administration a little bit. So, so the block size. So only thing we have to worry about is block size. Okay, and then this is bytes. So what will happen is that this is 1 byte is 4 kilobytes. I mean 4096 byte is 4000 kilobytes. So you could write 4K. Okay? I think I have to explain this here a little bit. You know what? Yeah, the time is up here. So let me stop this here, and then we'll catch up where we left off today. Okay? All right. So use the chat for you if you have any problems or questions, and then we'll catch up tomorrow. Okay?
Well, make a correction in the command PROTech. It should be dev, right? DEV.
Yeah, that's correct. Dev. SDB. Okay. All right, we'll catch up tomorrow. Thank you.